Alright, so we're going to do problem 736 here. Moving on to the test apps here, we know P1 is going to equal 100 kPa, T1 equals 20 degrees Celsius, volume 1 equals 500, changing that. We know that isentropic. We know that this will equal M1, and of course we know that volume 2 equals volume 1 divided by 8. Getting the correct answers that we saw as well in the manual solution. For state 3, we know that temperature equals Kelvin. We know that the mass stays the same. And of course, we know that the volume is going to equal the same as volume 2. Perfect. Now for state 4, we know that this will equal S3. This will equal M1, of course. Volume 4 is going to equal volume 1. Alright, so the graphics panel will show that these states are isentropic. Moving to the I/O panel, we can show that Qin equals M1 times U2 minus U1. Qout equals M1 times U4 minus U1. Qnet will equal the difference between them. Wnet, of course, equals Qnet. The efficiency will then equal Wnet divided by Qin. 74% efficient. And finally, our MEP will equal Wnet divided by the volume between state 1 and state 2. There we go. Alright, so we're going to go ahead and super initialize this. And we're going to go ahead and change the compression ratio to 12, the pressure at P1 to 150 kPa, the temperature T1 to equal 30 degrees Celsius, and finally the temperature at T3 will equal 1100 Kelvin. Moving on, we said pressure at P1 was going to change to 150 kPa. The volume is staying the same. And the temperature was changing to 30 degrees Celsius. State 2, mass will stay the same. Divided by 12 here. Solutions matching our manual solutions here. State 3, temperature changing to 1100 Kelvin. Mass, of course, staying the same. Volume here equaling volume 2. At state 4, we know that this will equal S3. Mass will stay the same. And the volume here will actually equal volume 1. Perfect. Graphics panel indicates they're isentropic. The I/O panel we can show So here we can see that the efficiency changed to 80%, whereas it was 74% in the last solution.